So today we're going to be learning about 15.1 and 15.2, which is interior and exterior angles of polygons and isosceles and equilateral triangles. We know that the sum of the interior angles of a triangle equals 180, which therefore means that 27 plus 82 plus x equals 180. If we combine like terms, we get 109 plus x equals 180, so x equals 71. When we go to the next triangle, we have three different angles. So we know that 90 plus 2x plus 1 plus 5x plus 5 equals 180. This gives us, if we combine like terms, 7x plus 96 equals 180, which gives us 7x equals 84, which if we solve for x, then we get x equals 12. Now, once we know x is 12, we need to plug it in right there to get measure of angle A. So measure of angle A is 2 times 12 plus 1, which is 25 degrees. And there's measure of angle A. Now we're going to go to naming polygons. So a three-sided polygon, we all know that name, is a triangle. Four-sided is a quadrilateral. Five-sided is a pentagon. Six is hexagon. Seven is heptagon. 8 is octagon. 9 is nonagon. 10 is decagon. 11 has two names. Sometimes it's called an undecagon, and other times it's called a hendecagon. So we're going to call it a hendecagon. 12 is called a dodecagon. And 13 is called a tridecagon. And an n-sided shape is called an n-gon. Now we're going to talk about the sum of the interior angles of a polygon. So we're going to start out by looking at a triangle. And if you think of a triangle and you're trying to draw number of triangles from one vertex, so if I draw the triangle here, there's no triangles I can draw from any vertex. So that means the sum of those are 180 degrees. If we're dealing with quadrilateral, which we see right there, and we're looking at, let's say we take this vertex and we want to draw all the triangles from that vertex. We can draw a diagonal right there. And how many triangles did we make? 2, which means if we look at the sum of the interior angles, that would be 2 triangles. So 360 degrees. If we go to a pentagon and we pick this vertex, that's a side, so we can't draw it there. So we draw right there, and we draw right there. How many triangles did we make? 3. And so 3 times 180 makes 540 degrees. Then if we go to 6 and we go from this vertex, draw 1, 2, 3. So we have 4 triangles. 4 times 180 equals 720 degrees. Then if we go to the 10-sided, we can draw one there, there, there. It's kind of hard to see them. 3, 4, 5, 6, 7, 8. So there's 8 triangles. And then if we look at that and we go 8 times 180, that's going to be 1,440 degrees. So what are you noticing about these? You should notice that the number of sides minus 2 is the number of triangles that you're making. If you notice that, number of sides minus 2. So if we go to the end, then we would have n minus 2. And how do we get the sum for all of these? We've always done 1 times 180, 2 times 180, 3 times 180, and so on. So the sum is just n minus 2 times 180 degrees. So the polygon interior angle sum theorem is just the same thing as saying n minus 2 times 180 degrees. Now for that, n represents the number of sides. So taking that and going to this problem down here, find the sum of the interior angles of a 20gon. So that means n is 20. So then if I plug it into the formula, I get 20 minus 2 times 180, which is 18 times 180, which if we multiply that out, we get 3,240 degrees. So a 20gon will have 3,240 degrees if you add up all of its interior angles. Now for number 2, it says find the number of sides a polygon has if the sum of the interior angles is 1620. So this time, we don't know what n is. But I do know our answer is 1620. So then I take n minus 2 times 180, and my answer is 1620. So how are we going to solve for n here? We're going to distribute that 180. So we get 180n minus 360 equals 1620. Add 360 to both sides, and we get 180n equals 0.891, 1980. And then 1980 divided by 180, we get n equals 11 sides. And we're going to go ahead and box that as well. Same thing over here with the 3240. Now, for this next one, it says find the measure of each. So I'm going to box that word each. In other words, it wants me to find all of them. And it says that it's a regular pentagon, which regular means all angles are congruent and all sides congruent. And so I want each interior angle. So if I can find the sum, all I have to do is take that sum and divide it by 5 because a pentagon is 5 sides. So n is 5. So then if I go 5 minus 2 times 180, and then I'm going to divide by 5 because I want each. I want to find how much each of them measures. So if I do that, I get 540 divided by 5, and I get each of them equals 108 degrees. That's how you find the individual. That only works if it's a regular polygon because it has to have all the angles the same for you to be able to divide by the number of angles there are. So now for this one right here, we're talking about a hexagon. And we want to know what the unknown measure. And well, we know from above that a hexagon's sum is 720. So if I add all these up, 69 plus 108 plus 135 plus 204 plus b plus 2b, which makes 3b, equals 720. Now, combining like terms, we get 516 plus 3b equals 720. So if I subtract 516 from both sides, I get 3b equals 204. Divide by b, and I get b equals 68 degrees. So now, since it wants the unknown angle measures, not only do I have to find b, but I have to find 2b. So if b is 68, that means 2b is 136. And now I've just found both angles. Now on to number 5. Since this is a quadrilateral, we know that the angles all have to add up to 360. So if we look at this, we have 2x plus 2x plus 20 plus 2x plus 2x plus 20, which gives me 8x plus 40 equals 360. Subtract 40, I get 8x equals 320, and x equals 40 degrees. Then we go on to the next one, and we look at this, and we know that it is a pentagon, and we saw from above that a pentagon is 540. So that means 2x plus 3 times 90, which is 270, equals 540. Subtract 270, and I get 2x equals 270, so x equals 135 degrees. Now, going to our next definition, or the next theorem, if we look at this triangle right here, this is considered an exterior angle. This exterior angle is equal to the sum of these two angles right here, the remote interior angles. So how we'd write that as a polygon exterior angle sum theorem is an exterior angle of a triangle equals the sum of the two remote interior angles. No, there's not a lot of room for you to write in these boxes, so we just made that fit. So if we go on to number 6, we know that this exterior angle is equal to the sum of these two exterior angles, which means 3x. So that means that 3x plus 7 plus 63 equals 5x plus 50, which means if we combine like terms, 3x plus 70 equals 5x plus 50. If I subtract 3x from both sides and 50 from both sides, I get a 2x equals 20, so x equals 10. Now, normally we'd be done, but the question's asking what's the measure of angle n, which means I want to take this and plug it in right there. So then I get 3 times 10 plus 7, which is 37 degrees. That would be the measure of angle n, which is what it's asking me for. So if we go to B, we know that the exterior angle is equal to the sum of the remote interior. So that means that 90 plus x plus 2 equals 3x minus 8. So x plus 92 equals 3x minus 8. So 2x equals 100. So x equals 50. Now the question's asking us to find PRS. So I'm going to take that, plug it in right there. And so I get 3 times 50 minus 8. 150 minus 8 is 142 degrees. So PRS is 142 degrees. Now, when we're dealing with polygons, the exterior angles of all polygons, it does not matter what kind of polygon we're talking about, they're always going to be equal to 360 degrees. So knowing that we're dealing with this polygon, with a triangle, the exterior angle is equal to the two remote interiors. But with a polygon, which any polygon, hexagon, it doesn't matter, all the exterior angles are going to add up to 360. So knowing that, we have 70 plus 60 plus 65 plus 40 plus y equals 360. This gets us 235 plus y equals 360. If we subtract that, we end up getting y equals 125 degrees. Now we're going to define what an isosceles triangle and an equilateral triangle is. And this is going to be a little trick for you. So with an isosceles triangle, most of you know that that means two sides are congruent or two angles are congruent. which is correct, but the actual definition is 2 or more sides congruent. 2 or more, and I'm going to underline and box that word more. So if we go to this right here and we're looking at the picture, we only see 2, but all 3 of them could be congruent and still be considered an isosceles. Now, when you're looking at this, you're looking at this with the 2 sides that are congruent. The angle between them is called the vertex angle. The other 2 angles are called the base angles. Now, if these 2 sides are congruent, then basically the angles across from them are also congruent. So, in an isosceles triangle, just going to abbreviate, base angles are also congruent because they're the angles across from the legs that are congruent. Now, an equilateral triangle is all sides congruent, which means this equals this equals this. If that's the case, then one of the properties of it is all angles are also congruent. The sides are congruent, the angles across from them are going to be congruent. So I always just draw an arrow. This is congruent to this, which is congruent to that. Now, knowing that, when we're dealing with this next triangle, 7a, we know that these 2 sides are congruent. If those 2 sides are congruent, it means that this angle and this angle are congruent. So if angle R is x, that means angle S is also x. And then knowing that a triangle adds up to 180, we have 3x plus x plus x equals 180. 5x equals 180. So x equals 36 degrees. But the question is asking us to find measure of angle T. So I'm going to take that and I'm going to plug it in right there. So the measure of angle T is 3 times 36 degrees, which is 108 degrees. And that would be what the measure of angle T is. Notice whenever we're talking about a degree measure, we always put a little m in front of the angle. So now we go to the next one. This is an equilateral triangle, which means all angles are the same. So if one of them's x, then all of them are going to be x. So then I'm going to say 3x equals 180. So x equals 60 degrees, which means the measure of angle B is 60 degrees. For this next one, I'm going to do the same thing. So these are my congruent sides. So these are my congruent angles, which means if Q is 3x plus 3, P is 3x plus 3. So if we add all 3 of those up, because of room that we have here, I'm going to go ahead and combine them. I have 6x plus 5x, which makes 11x. I have 6 minus 2, so that means plus 4, equals 180. Subtract 4, 11x equals 176. Dividing that, and you end up getting x equals 16. Now, the final question is saying, what's measure of angle P? So we're going to take that, plug it in there. So the measure of angle P is 3 times 16 plus 3, 48 plus 3, which makes 51 degrees. Now we're going to go to D. We know that this is both of these 2 sides are 10, which means that they are congruent. That means the angles across from them are congruent. So I'm going to call them both x because I don't know what they are. But I know that a triangle adds up to 180. So that means 72 plus 2x equals 180 minus 72, and I get 2x equals 108. Divide by 2, and I get x equals 54. So if x is 54, that means the measure of angle C is also 54, since angle C is x. Now we can also go the other way. Since all the angles are equal, what kind of triangle do we know this is? We know it's an equilateral triangle, which means that the sides across from that angle are all the same, which means what does that make x and y? It makes them both equal to 16. Now for this next one, we see that the angles are congruent, which means that these two sides are congruent. So therefore I can set 2x minus 1 equals to x plus 7. If I subtract x, I get x equals 8. Once we know that x equals 8, I'm going to take that, plug it in there because it wants to find out what AC is, and I get AC equals 8 plus 7, which is 15. And so AC is 15. Now we go to number 8. So now we're dealing with congruent triangles. So number 8 is saying if you know that two triangles are congruent, what else can we say? So if we know that triangle ABC is congruent to triangle ADC, then we can state all these different things. And we can just look at our two triangles to state it. We don't have to go over here and look at the picture. Then we know that AB segment is congruent to AD segment. We know that BC segment is congruent to DC segment. And we know that AC segment is congruent to AC segment. So that's by the sides. What else do we know? So we know that if these two triangles are congruent, then we know that angle ABC is congruent to angle ADC. We know that angle BCA is congruent to angle DCA. We know that angle CAB is congruent to angle CAD. Now, why did we have to use 3 letters? Why could we not only use one? We could have used one for angle B and angle D because there's only one angle there. But angle A, we can't use one letter because we have an angle A here, and an angle A there. That's why we had to say CAB and CAD. So if the two triangles are congruent, we know their parts are congruent. This, another way of stating that is CPCTC. What that means is corresponding parts of congruent triangles are congruent. In other words, C, P, C, T, C. It's a shortcut so you don't have to write all the words out. So when you're trying to prove parts of a triangle are congruent, so you had to have already stated that the two triangles are congruent, and then you're trying to prove parts, you can always end with C, P, C, T, C. The one thing you never want to do is you never, ever, ever mark what you are trying to prove in your triangle. So we're going to go ahead and do 2 proofs right now. So here we go. So in this particular picture, we're always going to start out with our proofs with going statements and reasons, statements and reasons. So this is what you're stating. This is the reason why. You do not ever mark your picture until you've made your statement. So R bisects QT. How do we know that? Because it gives us that, which means it's given. Now, if R is bisecting QT, what does that mean? It does. Bisect means it cuts it in half. So if it cuts it in half, it's meaning these two segments are congruent. So then I would state segment QR is congruent to segment RT. How do I know that? By definition of segment bisector. Now, remember what I was saying. Once you've stated it, then you can mark it. So now I can mark it. Those two segments are congruent. Now do I go to my next statement? Angle U is congruent to angle S. How do I know that? It was given. Now that I know that, I'm going to mark angle U and S as being congruent. So basically, you make a statement, then you pull everything you can from it. Make a statement. Is there anything that we can pull from that? No, there is not. So then I go to my next statement, and it's always going to be, what do they share? Well, they share this point. Anytime that they share that point, it means there's angles there that are congruent. So in this case, since they share that point, this angle and this angle are congruent. So I would state angle Q RU is congruent to angle TRS. How do I know that? Because they are vertical angles. So now that I stated they're congruent, I'm going to mark that they are congruent. Now, how do I know that the triangles are congruent now? So I'm going to cover one of the triangles. What do I have marked? I have two angles marked and a segment. Is that segment between the two angles? No, it is not. So it would be two angles and a segment. The segment is outside of the angles. So it'd be angle, angle, side. If the S was between, then I would have had to have been talking about this segment, but I'm not. Now, we've just proved the two triangles are congruent, so what can we conclude? We can conclude its parts are congruent. So therefore I can conclude that ST is congruent to UQ. Why was that? Because of CPCTC. Now, an easy way to remember CPCTC, I know it's really corny, but people remember this. Cows poop because they can. Just a quick way to remember it. It's a memory device. Just like you learned PEMDAS. Please excuse my dear Aunt Sally. Now, going on to the next one. So, VW is congruent to XY. Notice that's right up there, which means it's a given. And now that I've stated it, I can mark it. Then we have WX is congruent to YV. That's also up there, so that's another given. Now that I've stated it, I can mark it. Now, this is what they share. So they share this side. When you share a side, and it's the exact same side, it's called reflexive. Now, we're just going to put POC. POC stands for property of congruency. Because it's congruency, instead of writing all of that out, we're going to put reflexive property of congruency. Now I've stated that, so I can mark it. Now, the next step is that both triangles are congruent. So I'm going to cover one of the triangles. What do I have marked? 3 sides. So what would I put here? Side, side, side. And we're going to put the little congruent sign, which I forgot to put over here. The reason why we're putting the congruent sign, because there is such thing as side, side, side similarity, and we want to make sure we distinguish what we're talking about. So we're talking about congruency. Once we prove the two triangles are congruent, then we can go say their parts are. And that would be because of CPCTC. Notice we could not state this until we prove triangles. Same thing on this last one. We couldn't state this until we've proved the two triangles. And that is all for your notes. Hope you guys are having a great day.